Take a look at this number. Okay, what number is this? Well, it's 960 billion 100 million. This is a very, very big number. Okay, it's kind of hard to wrap your mind around how big this number is. What do you think this number could represent? Well, here's a clue. I'm going to put a $sign right here. Okay, and it turns out that this number is Canada's national debt in Canadian dollars. Okay, and it is huge. All right, now the way that in science we have of dealing with humongous numbers like this is called scientific notation. Okay, because it's hard to write out all of these zeros all the time. So what we do instead is write down just the significant digits. So in this case, we only have the first 4 digits are really important. So we can write down just those first 4 digits, and we'll always put a decimal place after the first digit. So 9.601, right? And then we'll multiply that by whatever power of 10 we need to get back up to the 960 billion mark. So let's figure out what that is. And we can do that by just counting how many times we need to move the decimal place to change 960 billion 100 million into 9.601. So if we start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that tells us how many tells us how many tens we need to multiply it by. So that's the power of 10 that we need to multiply 9.601. So it's 10 to the power of 11. So that is Canada's national debt in scientific notation. Let's take a look at another example. So 0.0000003, or let's think about what that is as a fraction. So we have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. So this is 100 millionths. So 300 millionths is a very, very, very small number. Okay, and turns out this in meters, so very small. Technically, we'd write this in something like nanometers or something like that normally. But this number in meters is the width of a polio virus. So a single polio virus ends up being 0.0000003 meters. Now, how would we write this in scientific notation? Well, once again, we would just write the significant digit. In this case, there's only 1 digit, so we don't have to worry about a decimal place. It's just 3. And then we're going to multiply that by whatever power of 10 we need to move the decimal place to the right spot. So in this case, since we're talking about a very small number, rather than having a power of 10 that is positive, we're going to have a power of 10 that's negative, because that's the direction we're moving the decimal. So we're going to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 spots to get the 3 right in front of the decimal there. And so that is 10 to the power of negative 8. All right, so that is how we represent this number in scientific notation. There we go.
All right, and now you understand how to convert from long form notation, or regular numbers, the way they're normally written, to scientific notation, and how to convert back. So there you go, conversion between notations, done. So that's it for lecture 4. It's been a long one, okay, but the good news is this is the last lecture of the first unit. So we will be having a review class on Thursday to cover everything, any questions that you have, and the test will be on Tuesday. See you then.